Hi, I am Himanshu, fourth year student of EC department, currently captain of Camber racing and fabrication lead of the team. My job in the team is to implement and fabricate the car designed by our team, and my main motive during work is to keep the precision to 0.1 mm so that we get the optimum performance as designed and simulated in the CAD. Also, as a captain, my role in the team is to manage the project and keep the motivation of the team high during the work.
I'm the design lead in Camber racing. The main issue which I faced is the previous CADs were very unconventional. The CADs were half in and out. I was to reverse engineer most of the stuff. And the other thing is, when it comes to CAD, there will be two things: the ones which you make and the manufacturing guys has to make it. And the other thing is, they'll buy the parts like brakes, which you have to basically, if you don't get the CAD for that, you have to reverse engineer it. The things which off by 1 mm or so, again, it will have a huge impact in assembly.
Basically, I am working on the car about 2 years on the braking system. Basically, our car is not topmost speed in India as 155 kilometers per hour. As when we are cruising, we need the brakes is the most important thing. So without an ABS system, we need to design the braking system. It's too difficult, and we face more challenges about it. So when we need to brake, the pressure need to overcome. It's not about the locking; it's about to stop the car. We are making the more different braking line system to the front and rear, and we're using different calipers to maintain the pressure in the equal to slow down the car as much as possible, about the safety of the driver and all. So we design as per the rules and regulations, whatever we have in that. So basically, the braking system is a very powerful now. I believe in that. Thank you.
So I wanted to improve the vehicle dynamics of the team. So in that we faced the problems in the budget constraints. So where before we used a better suspension, we got down to an Indian brand. So facing that as a problem and adapting the suspension made us face different difficulties in tuning the suspension, like auto angles, camber angles, everything. It was a main problem. So after fine tuning that, we got the very good and spectacular car.
I look after the design and technically I'm the chassis lead of Camber Racing, and also I'm the project manager, so a lot of roles. So looking at the design part, people will always ask like, okay Rohit, this is wrong, just do something else, change the design, it's too heavy, it's breaking or anything. I just get a brainstorm like running in my head. I just change whatever needs to be changed.
I'm the aerodynamics and simulation lead for Team Camber Racing. I've been in this team for the past 2 years. I've been to 2 competitions, namely Supra and Formula Bharat last year. So I take care of the simulations regarding the chassis, your impact analysis, your CFD analysis, your basically your aerodynamics of the whole car. So the first and foremost, simulation, modeling, and aerodynamics in general requires a lot of computational power. So getting necessary equipment in terms of a powerful laptop or something is absolutely necessary. So apart from that, you need softwares, really good ones. So when we first started out, we didn't have ANSYS with us, it was just a student version. So you are limited to a certain number of simulations you can run. But after our performances in the past 2 competitions, we got sponsorships from them where they provide us with licenses for their software, which is equivalent to that of what they get in the industry. With the help of that, the current chassis is developed. The analysis for the chassis was done using that, and the future iterations for the chassis and the aerodynamics will be done as well.
When it comes to driving an FSA car, it is very much different from road cars. Road cars have a lot of role going on that an FSA car is much more direct when compared to a road car. And especially this car that we built, it is very direct. It basically does whatever you want it to do. Before you think it has done it. In terms of driver safety standards, we have impact attenuators, we have race suits, we have harnesses. Without all this, it is
a very risky, even with all this, it is a very risky affair.
And I'm working on the electrical domain. And in the car, we have developed a quick shifter using the rest dynamic ECU in Powertronics. As well as I have made a customized dash so we can show the RPM and the gear in there itself. So we have included all the sensor which is crawl compliant in the car itself.
Hello, I'm Francis and I'm working as an electrical and intake engineer in Camber Racing. So in Formula Student cars, our main constraint in intake system is having a specific size of intake to reduce and match competitiveness of all the cars. So our biggest feat is designing one of the lightest intake systems by using 3D printed composite materials, and we have achieved about 95% volumetric efficiency, which brings us very close to stock level performance of other engines. So that means we can achieve higher top speeds, we can perform better in all the competitions.
Hi, I am Shrishti Kumari. I am currently a corporate lead of Camber Racing. When I first joined Camber Racing, it's been a year here. At starting, I was like a very unknown person here. I didn't know many of the things, and throughout the journey I have grew with Camber Racing is a different aspect for me in my life. In every aspect, in classroom, in here, everything. I have worked on my communication skills. I have worked on my characteristics, my development. Now I know how to communicate with all the other people. I know many things about many of the sections that are here.